Hello learners, welcome back to my YouTube channel. I'm teacher Aden. We are in lesson 2 of the first topic in form 2, the structure of the atom and the periodic table. Here we are dealing with isotopes. Let's start by defining what isotopes are. Isotopes are atoms of the same elements that have the same atomic number but different mass number. That's the definition for isotopes. During the exam, you can be told what are isotopes. These are atoms of the same element that have the same atomic number but different mass number. But you can also define isotope in another way. You can say isotopes are atoms of the same element that have the same number of protons. The same number of protons but different number of neutrons. But different number of neutrons. That one can also give you marks. Next, let us see examples of isotopes. So here they are. We're having hydrogen as the element. Then it's having 3 isotopes: hydrogen 1, hydrogen 2, hydrogen 3. So the atomic number of hydrogen is 1, 1, 1. The number of protons are 1, 1, 1 because we said atomic number is just equal to the number of protons. But the number of neutrons in the first hydrogen is 0. The number of neutrons in the second hydrogen is 1. Then the second number of neutrons in the third hydrogen is 2. Remember, isotopes, they have the same atomic number, or they have the same number of protons, but they have different number of neutrons, or they have different number of mass number. So we can represent these isotopes in this way, isotopic representation, where we are going to take the chemical symbol of the element, then we are going to put the atomic number down there, then the mass number up there. So let's see again carbon. Carbon has also isotopes. We're having carbon 12 and carbon 14. So in carbon 12 and carbon 14, the atomic number is 6 because isotopes have the same atomic number, or they have the same number of protons, but they have different number of neutrons, or you can say they're having different mass number. So you can represent it in isotopic ways or representation. So oxygen and chlorine as the way you can see on the screen. So thereafter, let's go to energy levels and electron arrangement or electron configuration. Let's go. So we have seen energy level long time ago. We have seen it when we are dealing with the regions of an atom. So energy level is the region surrounding the nucleus, and we said where electrons occupy. Where electrons occupy. Energy levels are numbered starting with the one closest to the nucleus. So if you remember, the structure of the atom was like this. We were having a small central region, and we are having the outermost energy level. So the small central region was known as the nucleus. Then the other one was the energy level. So when we are dealing with the energy levels, we are going to start the energy level that's closest to the nucleus. So each energy level can accommodate a given maximum number of electrons. For example, we're having the first energy level. So the first energy level is the one that's the closest to the nucleus, and that one carries a maximum of 2 electrons. That means it cannot accommodate more than 2 electrons. Next, the second energy level carries a maximum of only 8 electrons. So the third energy level for the first 20 elements carries a maximum of 8 electrons. You have to know that. But if an atom is not in the first 20 elements, its third energy level carries a maximum of 18 electrons. So kindly, you are supposed to know this, because if the atom is from the first 20 elements, it will have 8 electrons, or accommodate a maximum of 8 electrons, and it is third energy level. But if it is not, it's going to take 18. You have to know that. So after that, let's just try to go electron configuration. Electron configuration can also be called electron arrangement. Electron arrangement. So what is electron arrangement, or what's electron configuration? So electron configuration, this is the distribution of electrons into the energy level. The distribution of electrons into the energy levels. Okay, for example, so for you to do this, you are supposed to know only the atomic number of that element or atom, or you are supposed to know the number of electron of that atom. Okay, hydrogen has 1 electron, so its electronic configuration is 1. Helium has 1 electron, hence its electron configuration is 2. Lithium is number 3, so its electron configuration will be 2 1, because the first energy level will carry a maximum of 2. So it's having 3, that means the other electron has to go to the next energy level, that's the second energy level. So a total, you are going to have 3 electrons. So oxygen has an electronic configuration of 2 6. The atomic number of oxygen is 8. So the first energy level carries a maximum of 2. Then that means the other 6 remaining will go to the second energy level. So there we're having 2.8 as the electronic configuration for that oxygen. Next, let's go for sulfur. Sulfur has an atomic number of 16. That means for you to do the electronic configuration, the first energy level will take 2. Then that means the remaining 14, 8 of them will go to the second energy level, because the second energy level carries a maximum of 8. Then the remaining 6 will go to the third energy level. Then calcium has an atomic number of 20. So for me to take this 20 into the energy level, or for me to distribute them into their energy levels, we are going to have 2 for the first energy level. I'm remaining with 18. So 8 of them will go to the second energy level. I'm remaining with 10. So again, the third energy level, because it's the first 20 elements, it will take again 8. Because remember, we said the first 20 elements, the third energy level carries a maximum of 8. Then we are remaining with 2. That 2 will be in the fourth energy level. If you just try to add all this, you are going to end up having 20. So let's try to go to draw that atomic structures, or we are told draw and show the electron arrangement of the following atoms. So we're having boron. Boron is having 5 electrons. So first of all, for me to draw, I have to get the electronic configuration. So if I'm having 5 atomic number or 5 electrons, so I'm going to get 2 for the first energy level. I'm remaining with 3. Those 3 will go to the second energy level. So the electronic configuration for this boron will be 2 3. So for me to draw, I'm supposed to draw the nucleus. What you can do is you can shade the nucleus. Or if you don't shade the nucleus, you can write the chemical symbol for that boron. Or you can write the number of protons and the number of neutrons in that side of boron. After that, we go to the first energy level. Remember, we said the first energy level carries a maximum of 2. We have written there. So you can put the 2 using a cross, or you can use dots. Then we are going to draw the second energy level. The second energy level of boron carries 3. So this is the first one, the second, the third. So if you are told draw and show the electronic configuration of the poly atom, boron will be like this. So to show the electronic configuration, it will be 2 for the first energy level, then 3 for the second energy level. We're done with boron like that. So let's go for phosphorus. Phosphorus is number 15. So let's try to draw to write the electronic configuration. Electronic configuration. It will be 2 for the first energy level. 15 minus 2, that's 12. Then 8 for the second energy level. 15 minus 8, that's 5. So that 5 will go to the third energy level. So let's just try to draw the nucleus of that phosphorus. I can shade in the first energy level. In our case here, I want to use inside the energy level 2 electron. So second energy level carries now 8, as you see on the electronic configuration. So I'm having something like that. Then I go to the third energy level for that phosphorus. It's carrying 5 electrons. So this is 1 2, then I'm having 3 4, then I'm having 5. So I'm done with drawing and showing the electron arrangement of that phosphorus. The electronic configuration for phosphorus will be 285. Okay, let's go for the last one. I'm having potassium. Potassium is number 19. So to write the electronic configuration, I have to have 2 for the first energy level, 8 for the next energy level, again 8 for the third energy level, because potassium is one of the first 20 elements. So 1 for the last energy level, the fourth energy level. If you add all this, you are going to get 19. So to draw, I have to have the nucleus. I can shade the nucleus or write the chemical symbol for the potassium. The next, this example, I want to use dot. So the first energy level carries 2. Second energy level. Second energy level carries 8. So I'm supposed to use 8 dots. 3, 4, 5, 6, 7, 8, like that. Then the third energy level again carries 8. So 1, 2, 3, 4, 5, 6, 7, 8. Then the last energy level for this potassium carries 1 electron, and that's the electron, this electron. So that means I've drawn So the electronic configuration, I've shown it. So students, next we are going to go to the extended question. We have 2 extended questions. You are supposed to do it and try to share your response and your answers on the comment section. So let's now meet on our next class as we look on the periodic table. On top of that, you are supposed to know the first 20 elements in the periodic table in your fingertips. So we're having as our first element as hydrogen. We're having helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminum, silicon. We're having after that phosphorus, sulfur, chlorine, argon, potassium, and also calcium. Those are our first 20 elements in the periodic table. So if you know these 20 elements in the periodic table overhead, that means you know a lot. So for you to remember or to have this one on you memorize, we can have a formula. Inshallah, that formula, I'm going to share it in our next class, inshallah. So goodbye, thank you.